Welcome to the lesson on sampling distributions part 2. We're going to describe sampling distributions. We first need to think, how trustworthy is a statistic as an estimate of a parameter? To answer this question, we need to look at the shape, center, and spread of the sampling distribution. We will first start off with center, and we're going to think back to the reaching for chips activity we did and determine whether or not, when we found the mean of our p-hat values, whether or not it was a biased or unbiased estimator. How well did the sample proportion of red chips estimate the population proportion of red chips? Well, our proportion, population proportion, P, equaled 0.5, 50% of the 200 chips were red. And our sample proportion, p-hat, when we calculated the mean of all of them, was very close. It was approximately 0.5. So what does that tell us? That tells us that p-hat is an unbiased estimator of p. So a statistic used to estimate a parameter is an unbiased estimator if the mean of its sampling distribution is equal to the true value of the parameter being estimated. Now on to spread. Low variability is better. Larger samples have an advantage. They are much more likely to produce an estimate close to the true value of a parameter. There are general rules for describing how the spread of the sampling distribution of a statistic decreases as the sample size increases. An important fact to remember is that the variability of a statistic in repeated sampling does not depend very much on the size of the population. So we need to define what a variability of a statistic is. The variability of a statistic is described by the spread of its sampling distribution. The spread is determined primarily by the size of the random sample. Larger samples give smaller spread. The spread of the sampling distribution does not depend on the size of the population as long as the population is at least 10 times larger than the sample. So the general rules again for describing how the spread of the sampling distribution of a statistic decreases as the sample size increases is the spread is determined by size of the sample. Larger samples give smaller spread, and the spread of the sampling distribution does not depend on the size of the population, but the population needs to be at least 10 times larger than the sample. All right, in summary, a parameter is a number that describes a population. To estimate an unknown parameter, use a statistic calculated from the sample. The population distribution of a variable describes the values of the variables for all individuals in a population. The sampling distribution of a statistic describes the values of a statistic in all possible samples. A statistic can be an unbiased estimator or a biased estimator of a parameter. Bias means that the center, the mean, of the sampling distribution is not equal to the true value of the parameter. And the variability of statistic is described by the spread of the sampling distribution. And remember, larger samples give smaller spread. One last thing to take into consideration. When you're trying to estimate a parameter, choose a statistic with low or no bias and minimum variability. Don't forget to consider the shape of the sampling distribution before doing inference. Thank you for joining me on the lesson of sampling distributions, part 2.